it's a little bit more on the fun side. So I hope not to bore you too much, but I think you'll enjoy it. This is the 4 golden signals and the little push that could. But first, of course, I want to thank you for joining me today. This is written for anyone with who works with monitoring and alerting, is just interested in the SRE book from Google, or anybody just needing a good chuckle, 2020. So as Eva Maria mentioned, I'm Travis DePuy, product evangelist and integrator of things at xMatters. You can find me on all the assorted channels. But let's just get in. So the 4 golden signals are laid out in the Site Reliability Engineering book from Google. I could do the standard, PowerPoint slide thing and bore you all, but instead I made this little fairy tale to better demonstrate the various aspects of alerting and monitoring, especially laid out as the book, the handbook, as I like to call it. And again, since it's a fairy tale, the standard, agenda slide didn't really seem to fit, so I've come up with a nice little roadmap. So our story will begin with the 2 plucky SREs, Miss Goldilocks and Little Miss Muffet, as they tend their flock of microservices. Our friend Roger will share his wisdom from the book, and a chance encounter with Jeff the Aardvark will show them what the real world looks like. Our friend Kevin will share some nuts of wisdom around alerting, and then finally we'll see the little push that could. So without further ado, our story begins once upon a time. Once upon a time in a sunny valley, there was a company called The Farm. They provided digital services for delivering medication. As such, they had a flock of microservices. There was WebUE, providing the web user interface, APU, providing the developer API, UserDB, and all of their friends. The flock of microservices overseen by the resident operations team, Little Miss Muffet, standing in at 6'3". She likes curds and whey and does not like spiders. Her teammate, Miss Goldilocks, likes porridge, does not like hard beds, and is prone to breaking into cabins. The engineers watched with tender and care, and one day while inspecting the Docker docs, Miss Muffet asked Miss Goldilocks, "How do we know the health of our services? How do we know if there are any disturbances?" "Well, I'll poke it with a stick and I'll give it a look for a tick. They're all good if they only move a hair, and they're all good if I only see hot air." "Well, okay, I'm guessing that if you give it your blessing, we must be in good shape, but it seems to me as thin as a crepe." One night, after a hard day of wrangling microservices, Goldilocks falls asleep. And she wakes up at Nomad Creamery in a far-off land called Nashville, Tennessee. "Hey, check out this new dashboard. I love it. We have so much insight into the health of our services, and our sales have improved due to our higher uptime. Roger and his book really helped us move out of the dark ages and poking things with sticks. We can even plan for our projected growth based on current and past usage." My, oh my, what are these tricks? Could they be better than poking with sticks? The next day at the farm. Wait, so let me get this straight. As I'd really like to replicate, they watched their services hoard from a microservices dashboard? Yep, that's what I'm saying. They mentioned the name of Roger, who might be the old codger that guzzles gallons of caffeine like a car chugs gasoline. "Hey, Mr. Roger, we found your nice neighborhood. We'd like to know if our services are all good. I want to ask, is poking with a stick the best, or is there something better that you can attest?" This humble owl advises that to avoid surprises, you should be witness to your system's fitness. Fear you should not. The SRE Handbook you need. Wisdom and forethought, these are the things to heed. Within this truly epic tome, you will find the home of the golden signal sign to give you a monitoring baseline. The SRE Handbook from Google lays out in great detail how Google develops, maintains, runs, and monitors their microservices. You may have heard of some of these services such as, well, Gmail and Google Maps. And they've gotten pretty good at it over the years. So they decided to share their knowledge. The engineers compiled their years of experience into this book, and one such chapter goes into detail about monitoring, and it lays out the 4 golden signals: latency, errors, traffic, and saturation. Just think, let's monitor. These are important signals because together they represent the system from the application as well as the user's perspective, but they also provide metrics which can be useful for future planning and debugging. So the first golden signal is latency. This is the amount of time it takes to service a request. For typical request and response applications, this is measured in seconds per request. Raise your hand if you're a gamer. Ever lagged out at the wrong time? Yeah, usually this is due to latency. Here's a short video demonstrating this latency. A couple things to keep in mind. It's important to differentiate between latency of errors and successes. If your pages are serving 500s, but they take, that's HTTP 500s, but they take 30 milliseconds to do so, it will skew your latency graphs inappropriately. So don't count the errors. The second golden signal is errors. Generally, errors are bad. They can cause unexpected states, corrupted or unreadable data, and probably cause users to find something else to do. The signal associated with this metric is the rate that requests are failing and is generally measured in errors per second. The SRE Handbook lays out 3 different kinds of errors: explicit errors, implicit errors, and policy errors. Let's dig into those in a little bit more detail. Explicit errors generally indicate that something is broken, and they tend to be rather public and messy. For HTTP requests, this is a standard for HTTP requests, there is a standard for what a server should respond with. And anything in the 500 range is considered an error on the server side. Fortunately, this standard is well documented by the people over at httpstatusdocs.com. Some of my favorites: the 500 error, generally something bad happened. 503, service unavailable. It's there, but unable to respond properly. 504, gateway timeout. Sorry, I took too long. 507, insufficient storage. Whoa, too big. And while not technically a 500 error, my favorite, the 418, I'm a T-bot. The second type of errors are implicit errors, and these are a lot more subtle. So they might be a good response code, but wrong content or some other programmatic issue. An example is when a request is successful, but it contains, quote unquote, the wrong information. So here we might see a catalog. This returned maybe a 200 response code, but there's no products. So this would be an implicit error, could be an implicit error. These can be really tricky to track down because they have to be caught with careful testing. The third type of error is policy errors, and these occur when a policy violation happens. For example, maybe we want 95% of requests to be fulfilled in 2 seconds and 99% of requests to be filled in 2.5 seconds. This would be a policy or an objective that we would monitor for an error when 1% of requests start to take more than 2.5 seconds. Note that for monitoring a scale, some metrics you want to trigger a violation on a percentage rather than a raw count. So if you think about billions of requests per day, per week, that erroring on a set number of accounts can cause overloading your alerting applications. The third golden signal is traffic. This is how many visits to your websites. Are there too many? This is measured in HTTP requests per second. Other services might use different metrics. If anyone ever used different protocols, I'd be interested to see if you guys are measuring this, maybe bandwidth for streaming or otherwise. The final golden signal is saturation. This is a measure of how full your service is, and it depends on the constraints of the system. So it might be RAM or storage or CPU. Note that this also talks about the measure of impending saturation. I also had worked with an ops guy who used to talk about a disk that is normally running at 80 or 90% full, but it doesn't make sense to trigger a violation. But a disk that's on track to fill up in a few hours or minutes even is a sheep of a different color. This metric can also be related to queuing. For example, maybe you have a service adding more items into a queue faster than they can be consumed. You might have a degradation in the overall service as the consumers struggle to keep up. Other uses for the signal are fine-tuning the application or right-sizing resources for cost savings. But this can also be useful for future planning. After several months, you can amass enough data to start predicting future resource consumption and then start budgeting accordingly. So just think, let's monitor. Wow, that's neat, but it seems abstract. Have you seen a practical artifact? One that we could learn and emulate and then hopefully activate? How would I know? For I'm just an owl in a tree. Now leave me be so that I may drink my tasty coffee. Dejected, the girls wander back to the farm. They try to imagine the real world applications of the golden signals, but then they hear a rustle in the bushes. Psst, I heard you want to know about monitoring in the wild. Why, yes, that would be amazing to see you appraising how is monitoring styled in the real world wild. My dudes, what's up with the rhymes? Well, you're in luck. I'm Jeff the Aardvark, and I oversee operations at a company called xMatters. xMatters helps minimize the blast radius when stuff explodes. We track people down using on-call schedules, light up their devices to deliver critical information to the right people, and but getting the notification is rarely the end of the incident or the issue, and sometimes it's just the beginning. So we help facilitate the on-call notification and then workflow so that you can have peace of mind. And it's all free for 10 users forever. But as a digital service, there are microservices that support the product. So please step into my non-creepy villain layer and I'll give you a tour. xMatters runs on a microservice architecture. Some of the major ones, the web UI for providing the user interface, notifications for triggering the actual notifications to the devices, the xMatters API for the REST API, integration for service for executing asynchronous JavaScript, and RabbitMQ for assorted queues and event processing. Before we get into monitoring at xMatters, you might need to understand a little bit about the two sides of monitoring, white box and black box monitoring. White box is essential when collecting telemetry for debugging. Maybe a web server might seem slow on database heavy requests, but you need to know both how fast the web server perceives the database to be and how fast the database itself believes it to be. And this is where white box monitoring comes in. Think of white box monitoring as an X-ray into the service. You can inspect all the internals of the service from the inside. This is critical for debugging and finding the root cause of an issue. At xMatters, we use several different applications for white box monitoring. Prometheus for the internal metrics, which are exposed by each service through a metrics API that Prometheus then pulls to get these new values. This ensures that all metrics are dynamic and each service and alleviates the need for maintaining a static configuration file. And then when we add new services or metrics, we don't have to go update much of the monitoring. Additionally, we use an agent deployed from a SignalFX to get the infrastructure details such as CPU, memory, and network bandwidth of the Kubernetes clusters running the individual services. We round out white box monitoring using Splunk, which collects logging from the various services and aggregates them. After all, no one wants to track down logs in 20 different pods scattered across several different regions. Splunk also provides a repository to inspect the historical trends on usage and errors. But white box monitoring doesn't provide the full picture of the system being monitored. It needs to be in place alongside black box monitoring. If you're relying solely upon white box monitoring, then you aren't aware of what users are seeing. Black box monitoring is the view from the outside. So you can detect maybe when a service goes to sleep, or maybe like a load balancer issue when the white box monitoring says that your service is groovy, but really nothing is actually accessing the service. At xMatters, we do a lot of inspecting of our service from the outside, primarily using Pingdom. This gives us uptime checks from across the globe and provides a way to do scripted login so we make sure that users are getting the required service level. Our API is monitored using RunScope, which allows us to do synthetic API calls, and then inspecting the payloads. This can also help check for those pesky implicit errors. Why, thank you, Jeff. I can see we are running deaf. This has been an excellent illustration, and we must go make our own implementation. A short while later. All this monitoring gives us such good insight. I might be able to sleep through the night. Look, look, comrade, our dashpad isn't half bad. We have come to this day that I can throw this stick away. But later that night, little Miss Muffet went to sleep. And she wakes up at Nomad Creamery. Whoa, where am I? What's that thing in his hand? Oh, it's doing something. It's some kind of alert about his microservices. We should do some alerting, then I can take a vacation. I wonder if Roger the Owl knows anything about alerting. So the next day at the farm. And then his phone showed him a notification. No way, if we did that, I could take a vacation. I know, right? Let's go see if Roger can shed some light. I have been averting this thing you call alerting, but I will make a deferral to my friend Kevin the squirrel. Whee! Kevin? Did someone say Kevin? Who said Kevin? He's had too many coffee shots and I can't handle the watts, so I do believe I will take my leave. So you want to know about alerting. I know about alerting. Monitoring without alerting is like an oak tree that never drops the acorns. Alerts need to drop off the tree in order to be fruitful. They need to reach a human to deliver the information to those who can act on it. This is alerting and notifying. I don't put much stock in books, but I've come up with some best practices around alerting. Good alerting has 4 best practices. Kevin! Number 1, SLO alignment. If it isn't an SLO or in support of an SLO, then why do you care? If you care, but it isn't an SLO, then maybe it should be. Number 2, please, for the love of Pete, don't melt everyone's phone every time. Getting paged is disruptive, and cycles spent dealing with pages are cycles taken from feature velocity. The handbook that Roger goes on and on and on about seems to think it's good for on-call resources to spend more than 50% of their time doing feature work. So if they're spending more than half their time putting out fires, they're not being as productive as they should be. Along these lines, when pages occur too frequently, employees start to second guess, or they skim, or even ignore incoming alerts, sometimes even ignoring a real page that gets masked by the noise. The third best practice to remember is that alerting via distribution list is just spam. Using a wide rake is great for leaves, but terrible for acorns. Everyone gets too many emails, so why would we send alerts to people who are not responsible for addressing them? Using the escalations on alerting platform gives auditable data who responded on alert when. If the primary on-call is not responding, target the next person, and so on, until someone is found to deal with the issue. Number 4, go beyond alerts. Alerts should be actionable. As I mentioned earlier, the notifications are not the end of the issue. There's There's steps that have to happen after the notification. So provide response options to be able to take action, maybe open a chat, create a ticket, execute a runbook. Thank you so much, Kevin. This will help us find alerting heaven. No problem, kids. Kevin! With our alerting hooked up, we won't have to pray that they stay up, and we could go play some croquet on our nice town vacay. I'm so happy we're taking vacations. Now let's go have some tasty libations and renew our lease on some mental peace. But suddenly, back at the farm, an avalanche in the valley knocks out several microservices, and they are down. The monitoring triggers the alerts, and the little push engine races off to the track to track down Miss Muffet, who's the primary on call, and later, if needed, Miss Goldilocks. The engine chugs up the mountain. I think I can, and gets to the top, and down the hill, and into town to deliver the message. Oh, a monitoring alert. My services must be hurt. Yes, I see there is a situation. Fortunately, we have some automation. My little green push that could. I need your help to make this good. Let's open a JIRA issue on the matter, or Miss Locks will be mad as a hatter. Then we'll need a rescue crew. Let's tell them it's a code blue. And once you get over that ridge, get the team on a conference bridge. I know I can. With a new JIRA ticket in tow, the little push that could made it back up the ridge to start the conference bridge. User DB is back in the black, and this is just a minor setback. Thanks to all these integrations, we've reduced our users' frustrations. There, all services are repaired. Don't worry, I've got it all squared. This has all been so clutch. Thank you all so much. I give everyone high praise. Let's review the takeaways. The 4 golden signals: latency, errors, traffic, and saturation. But don't forget the 3 different kinds of errors: explicit errors, implicit errors, and policy errors. And the 2 sides of monitoring: white box, and black box. And the alerting best practices: make sure that you have SLO alignment, don't melt people's phones, beware of distribution lists, and go beyond alerting. And they lived happily ever after. The end. That's it, guys.